Hello everyone, welcome you all to the next session on relations and functions of class 12 mathematics. Let's see what are we going to discuss in this session. Here we are going to solve a problem from exercise 1.1. Here it is. The first question says, determine whether each of the following relations are reflexive, symmetric and transitive. And the relation, we have few subdivisions and the first subdivision is here. The relation R in the set A, which is equal to 1, 2, 3 and so on, 13 and 14 is defined as R equal to xy such that 3x minus y equal to 0. This means that the relation between the elements in the first set x and the second set, first set and second set both are A here. The relation between the elements in the set A and set Y is given by the equation 3x minus y equal to 0. Let's see how to solve this problem. To start with, let us list out the elements of the set A and also of the element set R if possible. Let's see what else we have for A. For A, the elements are 1, 2, 3 and so on up to 13. So we have here 14 elements in the set A. And the relation R is defined by the ordered pair x comma y, where the relation between x and y is 3x minus y equal to 0. Now let's see how to list out the elements of R. Now before we list out the elements of R, we'll just look at the relation here. And the relation is 3x minus y equal to 0. Now from this I can write y is equal to 3x. So this helps me better to list out the elements of R. Now let me choose the values of x from which I can get the values of y. Now the elements are, x can take elements from 1, 2, 3 and so on. So let me start with the 1. So when x is equal to 1, y is equal to 3. So the first element in R is going to be 1, 3. When x takes the value 2, y takes the value 6. So the next element is 2, 6. When x takes the value 3, we see y equal to 9 and the next element is 3, 9. Similarly, when x takes the element 4, we have y equal to 12. So this gives us the element in R as 4, 12. When x takes the value 5, we see y takes the value 15. So this means that the next element should be 5, 15. Here we stop because there is no 15 in the set A. Do you see that? The last element in the set A is only 14 and we don't have this 15 in the set A. We know x and y both are elements of set A. And hence we stop with this, like the elements of R is going to be 1, 3, 2, 6, 3, 9, 4, 12 and we don't have 5, 15 and hence we are not going to include this in R. And from this we are not going to have any other element, like if at all I say x takes the value 6, I'll have y as 18. Again this will not be an element because we don't have 18 in the set A and hence the values of R stops here. That is R takes a value 1, 3, 2, 6, 3, 9 and 4, 12. So we have listed the elements of A and R. Let's go on to check whether they are reflexive, whether R is reflexive, symmetric or transitive. As we all know, if at all we have an element, say x, x belongs to R, then we'll call that R as reflexive. Let's see, do we have an element 1, 1? No. 2, 2? No. 3, 3? No. 4, 4? No. 5, 5? No, nothing. We don't have any element called 1, 1, 2, 2 and so on. And hence we write it like 1, 1, 2, 2 and so on does not belongs to R. So I hope you know what does this mean by. This is nothing but not an element. This is how we represent by the symbol. This is not an element of the set R. Hence we call R is not reflexive. That is, R is not reflexive because we don't have any element x, x belongs to R such that your x is an element of A. Okay, let's move on to see whether R is symmetric or transitive. Let's move on. Before we check for symmetry, I'll rewrite the elements of R here for your reference. So what are the elements that we had for R? It was 1, 3, 2, 6, 3, 9 and 4, 12. Now let me take the element, the first element 1, 3. If at all I have 1, 3, I should have an element 3, 1 which must be an element of R. Do we have something? Can you just go back and revisit your definition of symmetric? If at all I have an element called A1 and A2 belongs to R, that must imply me, that is this A1, A2 belongs to R should imply A2, A1 belongs to R. If this condition is satisfied, then we will call this R as symmetric. Here you take the value of A1 as 1 and A2 as 3 so that you can have 1, 3 is an element of R. But you don't have an element called 3, 1 in R. So 3, 1 is not an element in R. So you can see the definition is not true for even one element. Even if the definition fails for one case, you will call that the definition is not possible. That is, symmetric is not possible for the given relation. And hence we conclude that R is not symmetric in this case. Let's move on to check whether this R is transitive. So what is the definition of transitive? As per the definition that we learned in the previous session, if A1, A2 is an element of R and A2, A3 is an element of R, then we must have an element called A1, A3. If that element is also in R, then we can call R as transitive. Again, let's check with the elements of R that we have. I'll take the first element of the set R, which is 1, 3, and we know the second element in this first element should be same as the first element in the second ordered pair, like A1, A2. You can see A2 is the second element in the ordered pair and this must be the first element in the second ordered pair, and hence if at all I choose 1, 3 as an element, first element, I must choose the element that starts with the 3, for which I will go for 3, 9 or anything else. So there is the only element that is available in the set R. So I can choose only 3, 9. So the elements that are chosen here are 1, 3 and 3, 9, and this should imply me that 1, 9 should be an element in R. Now do you see an element called 1, 9 in R? No. Hence we call it like 1, 9 does not belong to R. So this means that R is not transitive. So we understand that the given relation is not reflexive, not transitive and not symmetric. And hence we conclude that R is neither reflexive nor symmetric nor transitive. I hope you are able to understand. Now, for a better understanding, I'll be working out one more subdivision of the same problem. Let's see what it is. This is the third subdivision of the first problem. Here, the relation is defined as R is equal to a set containing x, y. There is an ordered pair of x, y where y is divisible by x, where A takes the elements 1, 2, 3, 4, 5 and 6. Now, as we normally do, let's list out the elements of the set A and elements of the set R. So what do we have for A? A has the elements 1, 2, 3, 4, 5 and 6. So we have 6 elements in A. Let's move on to R. R is defined as a set of all ordered pairs x, y such that y is divisible by x. So this means that the second element in the ordered pair should be divisible by the first element in the ordered pair. Now, with this condition, let me list out the elements of R. So, if at all I start with the element 1, 1 and 1 will satisfy the given condition. That is, the second element 1 will be divisible by the first element 1. let me move on to the second element 2 from the set A. So if I consider 2, 2 comma 2 will be the first element that could be possible with R. That is 2 is divisible by 2. Now there are some more possibilities with the 2 that I have, like 4 is also divisible by 2, 6 is also divisible by 2. Hence the elements could be 2 comma 4, 2 comma 6, and I don't find any other element with starting with 2. Let me move on to 3 as we normally do. 3 and 3 is it's applicable here, and 3 and 6 because 6 is divisible by 3, 9 and 3, and similarly I have the values 4 comma 4, 5 comma 5 and 6 comma 6. So you have the values of R here: 1 1, 2 2, 2 4, 2 6, 3 3, 3 6, 3 9, 4 4, 5 5 and 6 6. So let's see whether this relation is reflexive, symmetric or transitive. Let's look for the reflexive. Yeah, I have 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. You can see this here. 1 1 is here, 2 2, 3 3, 4 4, 5 5, 6 6. So all these I have it in R. So this means that for all x belongs to R, I have x comma x. The set of ordered pair x comma x is also an element in R. I'm sorry, it should be for all x belongs to A. For all x belongs to A, we have x comma x belongs to R, and hence R is reflexive. I hope you understand this. Again, we have to check for symmetric and also transitive. Here, let's consider the element 2 comma 4, which is an element of R. Now, when 2 comma 4 is an element of R, we need to check whether 4 comma 2 is an element of R or not. Let's see whether 4 comma 2 is an element of R. We already knew from the relation R that we have defined, 4 comma 2 is not an element of R. Hence, we can conclude here that R is not symmetric. So this tells us that R is not symmetric because we don't have the element 4 comma 2 in the relation R. Now, let's move on to check whether R is transitive or not. To check transitive, I'm not going to consider any specific element in R. Instead, I'm going to take the general elements like x comma y and y comma z. As we know, the second element in the ordered pair must be same as the first element in the second ordered pair. So this gives me that I have to choose, if at all I choose x comma y as the first element, I have to choose y comma z as a second element. Now, when I say x comma y is an element of R, this means that y is divisible by x. Then, if I have an element y comma z in R, this means that z is divisible by y. Now, let me rearrange this relation, that is z is divisible by y and y is divisible by x. I'll rearrange it. That is, I'll write the second one first. That is, z is divisible by y and then y is divisible by x. Now, read this. Z is divisible by y and y is divisible by x. This means that z is divisible by x. That's what we have here. Z is divisible by x. When we have a relation that z is divisible by x, this tells us that x and z, the ordered pair containing x comma z, is an element in R. So we see that x comma y is an element in R and there is another element called y comma z in R. So when we have these two elements, and this concludes us that x comma z is an element in R. So this means that R is transitive. Hence, we conclude R is reflexive and transitive but not symmetric. I hope you would have got a better idea how to check whether the given relation is reflexive, symmetric or transitive. Now, with this understanding, I would like you all to try the remaining subdivisions of the first problem. I'll meet you in the next session by solving the second problem. Thank you.